Okay. So, we're going to look at method invocation twice. One as just an API. What is the abstraction? And then as something we're going to implement. Okay. So right now we're looking at it just as an abstraction. And as the name indicates, and as you guys have seen from part 1 and part 2, the idea is to go and make remote communication look like local method calls. So surely the design couldn't have too many subtleties, you would think. Okay? But of course, nothing is easy. So, so from what you guys have seen already, let's see. What do you have to know? And what did you miss out on when you tried to create your RMI application, which didn't work, beyond how to invoke methods, which we teach in CS1?
Well, mine broke when I tried to compile it with RMIC.
Oh, don't use RMIC. Don't use RMIC.
Okay.
Yeah. Use export object. So that's something. RMIC is just something I gave you in the notes to show what exists as an alternative. But you look at my stuff and do export object. Okay. So that's one of the things that some magic has to happen to make an object look like a remote object. That magic can happen at compile time, which is a traditional thing. And by the way, you guys, when you first downloaded Object Editor, it didn't work. It said util.listener not found. That's because I use RMIC for some aspects there. And I hadn't regenerated my proxy after changing the object. So there was a mismatch. And that's a problem with RMIC. Okay? So don't use that. So that's one of the things you might have to know. You have to somehow, if you use RMIC, that's something you have to know beyond elementary programming. That not only do you compile your program, you RMIC your program. Okay? What other things do you have to know to do remote invocation? Beyond how to invoke methods. So we know the methods are being executed in a separate process. Okay, that's the semantics. They almost look like, and that's one of the keys, that they almost look like local calls. So let's look into that. I said they almost look like remote local method calls. Why do I say almost?
You create an object, and then you call a method on that object. And
Yeah.
so from the outside, it looks like that's all you did.
So that looks like, but so why almost? Why not exactly?
Because really it's in the proxy within.
But that's underneath, right? That's implementation. That underneath it goes to a proxy call is made.
Yeah.
But as a caller of the method, do I have to be aware that it may be remotely invoked?
At least when you set it up.
Okay, so you have to set some things up. So let's look into that little next. But once things have been set up, does the method invocation look at all any different?
You have to know that it'll probably take a lot longer than a normal.
Okay, how much longer can it take?
It could not complete.
It could not complete. And how do I know that it didn't complete or the system has given up?
Exception.
So you have to deal with a new kind of exception. Every remote method call
That's a remote exception.
has a remote exception, which is checked or unchecked, or which should be checked or unchecked.
Should be checked.
Check.
So what distinguishes checked from unchecked again? Which exceptions do we make checked?
Ones you want to force the.
That's the definition of checked. That ones you want to force, and which ones do you force?
Ones that you could try again with the remote one. So
Once you can try again, okay. If you can try again, or there's a most subtle.
Ones that like the programmer can't be sure that he's accounted for.
The programmer, ones that are not under the control of the programmer. If the programmer can write better to avoid the array index out of bounds exception, then there's no one making it checked. Okay, but if the programmer is reading from the user and the user does end of file before the user should do end of file, or reading from a file that is corrupt, the programmer has no control. Okay, so the programmer has no control about the remote server. The remote server may crash. It may give an exception of array index out of bounds exception, or it may,
the internet may fail.
Okay. So in that, we already know that, the call looks different. You have to you have to, I mean, syntactically it's under Java's rules that, you just catch that exception. But for each of these calls, you have to catch that exception. So you can't take a local program and just convert it into a distributed program. You have to go and change things. Later, you'll see Gypsy, where I made a different decision. I didn't make it a checked exception. Okay, I'll lose some, but you gain a lot also. And one of the things you gain is that your local calls look identical.
So could there also be another way to do it where you return some special value?
So returning special values, what do you do about method calls? That's why we had exceptions, right? Exceptions is to avoid this error code business. So the other thing is to say that, look, yes, you can catch it, but if you've got a local program that doesn't catch it, let it run, and we'll just throw up an exception on the console. Is that so bad? Maybe it is. Okay, but that's certainly a second another choice. And a lot of things become more, So there are advantages that you can take existing programs, and you can invoke certain kinds of methods that you couldn't invoke otherwise, which we'll see soon. Okay, setting up. So how do we do setups now? When we did byte communication, what did we do? We had a client go and the client had to know about the server, host, and port, and it somehow got a handle that was used for future communication, right? Now, in remote method invocation, is that what RMI does, and is that what RMI should do? How do you get a reference to a proxy?
Yeah, that's the registry.
So there's a registry. We didn't have a registry in NIO case. Okay? So now the server has to go and say, I exist, and put it in a registry, and the client has to look up the registry.
Where is the registry? Is it just...
So the registry now we have a bootstrapping problem. How do I communicate with the registry? Registry cannot be at both the client and the server. So one of them has to do some remote communication. So to do remote communication, how to do remote communication, right? So the registry can be anywhere. And if you don't say anything, the registry is at the local computer. If in the bootstrapping mechanism you go and say this host and this port, then it is at that host and port. Okay. By default, the port number is I think 1099 at the local computer, local host. Okay. So we have now an interesting situation that there's a central database, and you don't have to. That's orthogonal to remote method invocation. So the system I have doesn't have a registry. You just say host and port number, and you get it. You just establish a handle just as you establish the NIO handle. Okay. Again, some pros and some cons. Okay, but just to show you that that's not inherently a part of RMI. In fact, there was a system called Cedar at Xerox where you didn't even do a setup. It was meant to be a local area network system, and the loader basically you could only have one instance of a module in the local area network, and you didn't have instances. You just had classes. You were just calling class methods essentially. So by just going and saying class.method, you automatically went to a remote host if that class had been started at that remote host. So the idea was that you're going to contact the file server. There's only one file server. That file server module was started off on host 2. So anyone who goes and says file server.method, goes to that host. And so there's no setup at all. So it's a completely transparent system. You could really take your local programs and convert them into distributed programs. Okay, but the constraint that you could have only one instance of a module. And this was not an object-oriented language. This was sort of a class-based language, a module-based language. Okay. And just to give you guys a little history, that language was based on a language called Mesa. Mesa is a language that influenced another language that's more popular called Ada. Okay, so that was an important system.
Is that the based off of Java multi?
Java was based on Mesa. So I was at a conference where Gosling, these Xerox guys, at that time Xerox guys were still going strong. And the Xerox guys, asked Gosling, so what innovations have you added to Mesa? And small talk, they said. And, he said, I didn't. So he basically didn't try to claim too much. Gosling was creating set-top boxes at Sun. He wanted a language which was not C or C++, so he invented Java. and people took, he didn't intend for it to be a language that academics discuss and criticize, and he just created something he liked, and so we shouldn't criticize it too much. Okay, so we might have a local counter that you want to increment and get value of. You want to make it remote. You have to create a separate interface where you go and say for each method here that the caller may get a remote exception. So the same class now implements two interfaces. One is a proxy, which is what this interface is, and one is a non-proxy. Okay, so already I can't just take my programs and convert them into distributed programs. Okay, using this. So caller should handle errors and is required to handle check exception. So there is some awareness. This guy who's making this call, that's a term we often hear, awareness. Whenever you provide automation, how aware are you that things are being automated for you? And if you're not at all aware, that's perfect automation.
So if something that was expecting a counter, but this thing is with a counter and a distributed RMI counter, when it calls increment, it wouldn't know that they could throw a remote exception.
So somebody who's dealing with, somebody will be either typing the object as counter or this. If they type the object as this, then they have to go and call this method.
Well, so you could have two increment methods in your class if you implement both.
No, you can have only one method that implements both. See, here's the deal. If my method does not throw an exception, but my interface method throws it, that's okay. If I always tell my 401 students, if your aspirin tablet says it can cause nausea, and it doesn't cause nausea, nobody's going to complain. It's only when so if you're good and you're bad, people will complain. If you advertise yourself as good and you're actually bad, people will complain. If you advertise yourself as bad and you're good, nobody will complain. So when you go and say, I am bad, I can throw this exception, and you don't actually throw the exception in your code, that's just fine.
Okay.
So this is the proxy interface. Remember, from the same object with RMIC, you would create another class, if you will. That's a proxy based on this class. This is the interface of the class. Okay? And it's just a counter interface. I want to make it distributed. So class header need not have throws class as interfaces used by client. Okay? And the only thing is that my equals method has to change, because you know how equals methods go. You go and check, is the object that I'm comparing myself with my type? If it's my type, I do something special. Otherwise, I just say super dot, or I just go and say, in this case, I just say false. Okay? Or I could do super if there's a super case. Okay? So my distributed RMI counter interface does not extend counter interface. That's very important. Okay? And here's my implementation of distributed guy. I extend a counter. I go and see I implement an extra interface. So I have to do that, by the way. So I can't just take my original code. But I don't have to go and change my headers here, because my headers implement both. Okay, both interfaces. But I did change my equals to go and say, if I'm not distributed RMI counter, I do super.equals. Otherwise, I go and check against the distributed RMI counter. Okay?
When you do the catch, is there a way to put it in a while loop so that if you catch an exception, you just
try again? You could do that, yeah. Why did you get an exception? And you'd probably look into that. I mean, this is a remote exception. It's a nested exception. It goes and says, I got this exception because of this exception. So you can probably analyze that and say, was it because of an array index out of bounds exception at the remote end that I got this? Or did I get it because of...
So when you get, the remote exception will be more detailed about another exception It's on the server.
Yeah, I'm trying to remember that if you have an array index out of bounds exception at the other end, would you get a remote exception or would you get a nested, would you get a null pointer exception saying it was nested? I know I've seen this message many times, nested exception is caused by that. But this may actually be just a timeout exception. And that if there's an array index out of bound exception at the other end, then you get a nested exception. I forget which way Java went.
So it's a remote exception caused by
Yeah. You do get this message, nested exception caused by this exception. I don't know whether the name of the nested exception is distributed exception or is it just an unnamed exception. Okay, but you will get an exception at the other end. Okay. So inherited methods implement two different methods, but then without throws clause. This is very important. So now my caller and callee to connect to each other, not to call methods. It's not as if this RMI registry is on the path to calls, but on the path to connection, it now has to go through a RMI registry. Okay. So you have to learn a lot. I mean, you have to learn enough to get confused, I guess, to use RMI. And it's just a name server. RMI registry is just a name server. Okay, and you find such name servers. And caller registers, name proxy, there.
So there is a way to connect straight from caller to callee.
No, not in RMI. Connect. When you make calls, they go directly to callee.
But I thought you said in yours
Yes. In mine, I do that. I don't assume a server. Because I feel it is a more basic building block. I can use my system to create an RMI registry. Whereas here, RMI registry is magic. So I like that design better. Yeah, I just had fun. When I was doing, I did my system just so that I could create a layered system so that you guys could play around with it. And then I said, hey, now I can become a designer. So let's go and see which way I can, go differently and see what the consequences are. We all want to be programming language designers to some extent, Unfortunately, existing languages are hard to replace. And for good reason. The English language has got so many flaws, but it's, After Chinese, is it the most popular language?
Yeah, it's number one, second.
I think it's Spanish.
Spanish? Or what about, the Indian languages, there's just too many. But, so anyway, just because it's
Depends
popular.
on if you count like
China is now the number one, second most English-speaking country in the world.
that's true.
Is it true?
Yeah.
Yeah. I think there's more people in the United States that speak Spanish than people in Spain.
I mean, even if 10% of Chinese people speak English, then
No, yeah, I think if you
No, come on. India's got higher population than China or lower right now?
higher, but I don't think
I
they're
think
they're not.
I absolutely don't agree with you that there's.
I think India's lower, but its trajectory is higher because China's growth trajectory is down right now and India's is going up. So there's a swap at some point.
Oh, India is not more than China, but India has to have more English-speaking people than China, as a fraction.
That's true.
It has to be.
Yeah.
It's taught in. What does English-speaking mean anyway? So
There are 1.1 billion people that speak Chinese, 414 million people that speak Spanish, and 335 million people that speak English,
okay,
and 260 million that speak Hindi.
yeah, India is too divided.
Only 350 million speak English.
335. That's what it's.
That's
Yes, the word "speak" is being used very loosely here. by
Yeah,
all
this
of us.
might mean like native speakers. It might not include.
Okay, so
still strange.
back to languages. Okay, so that's what's happening here. Okay. We have to create our RMI registry, and here's some code to do it. You go and say at what you are at a particular host. You go and say what port you want, and that's the default port, by the way. And why do you guys think? Do you guys remember from the notes why I put this?
So it won't stop.
It won't stop. Okay. So I don't want this main to stop. So I just do this. This is my simple way of doing it. Normally what happens, the server starts a registry itself. So there's only one registry per server, which is typically what's done. Registry is supposed to be something that's common to multiple servers at a host. And so when the server doesn't stop, the registry doesn't stop either. But here I've created that as a separate process just to show that's possible.
So this one, you just type in something
And you'll never type that, so it'll always,
okay.
that's my way of making it block.
I see.
I can make it wait on some semaphore, I can do many things. Okay. Okay. So it's usually started as a part of server process. And here's the server. And the server code is not too complicated. Firstly, it goes and says, find me the registry. And it just, since we are doing everything local, it doesn't give the host name. It says, find me the registry at my local computer. Okay? If you really wanted to register at another computer, you could register yourself with something at a remote computer also. Okay? I go and create my object, and I have to then send it to the registry. Right? So that's what this is doing. It's saying registry rebind. It gives it a name. Okay? So we are not talking of addresses any longer. We're talking of symbolic names that are separate from client and server, and gives it the object. Okay? And
So, I have a question about name. So you can define an arbitrary name, or you just stick to Java, the Java name.
yeah, so the point is that how do client and servers agree on a name? And I'm being very lazy. I'm saying, you know what, I have only one instance of this class. We both know what this class is called. So let the client and server both agree that it will be the class name. That's just my simple way of naming. I can put any name. I can put foo, bar, or whatever.
You could,
I have chosen this method so that there's less ambiguity.
could you also wait to create the object when the user first needs it?
Could you wait to create the object?
And then you could then attach the some instance information about that name.
So how would that work? My user, so your thing is that, look, let's do lazy creation of objects, You like that lazy question in pipes, I know. You're a functional guy. Of course you would like lazy evaluation. Now I know.
I do so much beforehand.
I always tell people lazy evaluation is good. Do your assignment the day before it's due. Who knows how I might change it. And let the other guys figure out the wrinkles, and then just you'll be efficient.
I would wait for an OS.
Did I tell you guys about the compiler contest?
Yeah.
Yeah. Okay. So you want lazy creation of objects. Okay? That if no client wants it, why even create the object? Now, how would you do that with the name server? You could, but just think about it. What would the API look like? I like this question. I'm saying this question because I'm thinking of an exam question right now.
You could have like some kind of call to the server where it's like, either give me the address or register me as the...
No, so what's the client doing? The client says, I want to look up. Later the client will say look up, right?
Yeah.
The server will, so the server has not given the server has not given the name server any object because the object is not being created. So what will you have to do? Client says, I want an object.
Yeah.
What the server will have to do is say not register, but it'll just register the name. It won't register the object.
And you can just rebind that object.
And then the server, when the name server is told look up, it goes and says, hey, you created a name, but you never gave me an object.
Yeah, so.
So it'll call back.
So the other question is, the more important name aspect, the name that gets from the client's end, right? So the client has could have a local instance, and then, or, and that, but that really it's on the server, but.
Yeah, the names both client and server agree on.
Yeah, I know, but I'm just trying to get at having multiple instances, because right now for.
No, yeah, absolutely. This call is a string. I'm assuming in this problem, and I do that in my solutions. When I don't have multiple instances, I just do this. Otherwise, I would go and do this and +1, +2, just have a systematic naming scheme. Not put foo and bar there, right? Again, I'm influenced by the Cedar guys in Xerox, which said, there's only one file server. Okay, so even I think file servers. Okay, but sure. So that's what you'll have to do. You'll have to have a rebind without an object. You'll have to have a callback. And in that callback, you'd return the actual object. Okay? What is this export object business? This is the key. Do you need to sit there, or can you see?
I can see, yeah.
Okay. If I don't do this export object, this program will work. I mean, it'll do something. It won't crash.
And that export object is doing what RMIC would have done?
Yes. Export object is doing what RMIC would have done, which means dynamically creating a proxy. And in some table, somewhere in RMI's space, it goes and says, this object counter is associated with a proxy.
What is the 0?
I forget what the 0 is. I think it's port number. Is that what it is?
Yeah, I think so.
Okay.
And that's just default.
Yeah. So it's doing an export. It's binding this export to some hidden proxy. Think of a hash table. In that hash table, it's saying the key is counter and put a proxy there. Okay?
Is it port the port number on the computer? Yes. What happens is that this really saying that whenever messages come to me, 0 means choose a default port. Okay.
Otherwise, because remember, this is a server. Underneath, there's some NIO channel or socket channel. Underneath, there's got to be a port number.
Okay.
The system can choose a port number, which is what the 0 means,
Okay.
or you can say give a port number.
Okay. I see.
Okay? And now the rebind is doing what exactly? What is rebind really doing?
It's associating that name.
Associate that proxy to a name.
Yeah. Associating this name with the proxy associated with this guy.
Yeah.
What are we getting out of the proxy? What's it?
A proxy is a handle that can be used at the remote end to call methods back at the server. So supposing I have a counter, and the counter has got this increment method in it, right?
Okay.
By creating a proxy, I send a proxy to another guy. When he calls increment, the increment of this particular counter is done rather than of some other object. So the increment gets forwarded back to me. That's the remote method invocation.
Okay.
The other end needs some handle, right? It needs to be able to, it needs something that looks like a counter. It gets something that looks like a counter that forwards its calls to this counter. So that's why it's a proxy.
Okay. So that's just part of the mechanics of the RMI.
Yes. Now, if I didn't have an export object, what do you think would have happened?
Not make it back when you make that call.
So what's the call going to be made on?
It's going left.
So you're saying the call will not be made back, right?
Yeah.
So the remote guy, who does a lookup, what will he get? Or what gets sent to the server?
A remote exception.
Remote exception? No, there's no exception. If you don't do this,
No class found.
no, the class is found.
It's you just send a serialized copy.
Okay.
So the name server is a name server for both remote method invocation and just keeping serialized copies of objects. Okay. So use default port. If you remove this, serialized copy will be sent if object is serializable. So the increment here doesn't affect the local client's counter if there's no export object. Otherwise, the increment here will affect what the client will look up. Okay.
Those seem like so very different behaviors. Like it seems like the code for rebind has like special cases.
Oh yes, absolutely.
For exported objects or not exported objects.
Absolutely.
It doesn't seem like something you could deduce by just looking at the rebind like statement and
But this is kind of true in parameter passing in Java. When I go and pass a parameter, and this is actually, I mean, this is important. There's really no way to get around this. So you guys all know Pascal? So in Pascal, there are var parameters and there are non-var parameters. You can send things by address or by. Now C, his favorite language, got rid of var, the keyword var. So now you have no choice. And Java is based on C. So your parameter never tells you whether to send a reference or not to send a reference. So how does Java handle that situation? No. But in remote case, what happens? In the remote case, either it can send the serialized object, or it can send a reference to the serialized to the object that can be used to invoke methods back. So what does it do? It says if the object is remote, then send a proxy. Otherwise, send a serialized copy. Okay, and that's kind of what rebind is doing. I mean, it's not quite that, but it's in the spirit of that. That says if it's been exported and it's remote, then I'll go and send a proxy.
So if you don't export, then the server is going to run the code for increment when people call increment on it?
No, when you don't do export, when people call increment, they do increment, they get the whole object, they get the whole file server in their client. And they do local invocations on the file server.
So they just get they get a local copy, or they get a local copy every time?
They'll get the same local copy. See, what happens is, first the thing is copied from the client, from the server to the name server.
Mm-hmm.
From the name server is copied back. So there's two copies made. So whenever they do a lookup, they'll get a separate copy. That's serialization.
So they're not their increments aren't persistent because they're getting a set.
Every time. It's just an object I created, I gave you.
So they get an object increment and throw it away, get an object increment and throw it away.
So you better have export object. If you miss it, you're in trouble. That is the key here from a practical point of view. Okay?
As a design point of view, I think that's ugly.
Well, I'll show you another way to get it. This is something I use. All your tutorials will tell you to do it in a different way. Okay, which you may or may not like. Okay? I don't like that very much, but it's safer. Okay? So when does server terminate? That's another question. So we talked about the name server. I put a read line there. I didn't put a read line here.
Because it's attached to the registry.
No, not because it's attached to the registry, because I could be sending only serialized copies to the registry. If I send only serialized copies to the registry, I don't have to persist. I persist if I have if I'm done, I shouldn't persist if I'm done. I should persist if somebody who depends on me is not done. How might somebody depend on me? If they got a serialized copy, they don't depend on me. So they depend on me if
They have the
RMI.
stored.
Sorry?
if the object is exported.
If the object is exported. If I remove that export object from this code, the program will terminate immediately.
So you mean if the last client is disconnected?
We don't know when the last client might exist because the last client may disconnect and may reconnect, so we just stay forever. There is no such thing as a last client, right? As long as I've told the name server I've got a proxy, I better go and be around to service methods invoked on the proxy.
So as long as counter is alive.
As long as counter is alive at the name server. And this is the same idea if you ever create a GUI in Java, the moment you do frame.setVisible true, the main method can terminate, but the process will remain. Because there's a GUI thread that's servicing it. If you don't do setVisible true, your main method will terminate. Same principle.
What if the name server dies?
I think you will get some kind of exception in the counter server, most probably.
Okay.
Should be the case. Okay. Main method will terminate, by the way. My process will not finish. My main method will terminate.
So
It's not as if that export object is like a blocking call.
So it's like a daemon.
Yeah,
process.
it just becomes a daemon. Yeah. Okay, so you will see that this particular process, it's not the main thread, but there's just other threads running. Okay.
You took the line out of it first time.
Why did I do it twice?
Because that's an example.
Oh yeah.
Yeah.
In one case there is no export object. Okay, and my client gets a registry. Again, it uses the bootstrapping method and does a lookup. And if the object was a proxy, it gets a proxy. Otherwise, it gets a.
Wait, so here it doesn't have to know the port of the registry of the server?
So it has to go in. Again, the client and server are both running on the same computer.
Okay.
Otherwise, it should go and give the port number. Okay, and it does a lookup on that name, and then now I can print out the value. Okay, so it's not too complicated. Just remember to export the object. Okay, so this is very important. I get a proxy object here too. This call, if this particular argument was some remote host, I am calling methods on a remote object. And that mechanism is very different than the mechanism here underneath. Okay, and this is what I unified in my system. Okay, that there's underneath, the client can see what's really going on. Okay, so this is all review actually of what we sort of did before in the previous two slide decks. Now we get into some interesting questions. And this is also a review, but let's see we do this. I'm here the server. Okay, I create two different counters, both instances of the same class, right? And I export both of these guys. I rebind them with two different names now. Okay. And then I look up counter one. So I deposited it. I looked it back up. So counter one equals counter two. These are both local objects. Should that return true? Assuming my equals works right. Okay. Should return true. Counter one equals proxy one.
Yeah, because you have the whole go to your superclass, right?
So
They would just have the value. It would just get the value of the block. Yes, no, it's stored.
So this should return true.
Yeah.
Counter one is the original object, and it's going and invoking the methods on the proxy, and those methods will be called remotely because it goes and says get value and so forth. Okay, so counter one's methods are called locally. The local things go and say, is my proxy a distributed RMI counter? If so, I'll do proxy dot get value, and I'll go and enclose that in my in my throws clause. So that should return true.
But the next one, when you do the hash code, what if you didn't do the hash code, just did the equals, and that would just
The equals will of course not return. Yeah. Should you know that two objects that are equal, supposing I go and
pointers, right? And you'd be comparing the.
but in the hash table they look at the hash code of the objects. So you can pass the hash code of an object changes as the object is changed. Because when the object's contents change, its hash code changes based on the contents. So the whole idea, the hash code for a hash table to work correctly, supposing you go and deposit something with the key foo, where foo is some particular object A. Now I create another string which is also foo, but it is at a different address. You can do that. When I go and pass the second string as the key, will I get back the object registered with the first key? So I have S1 and S2. They're both foo. They're both two different objects. I said hash table put S1 bar. Now I go and say hash table get S2. Should I get null or should I get bar? In fact, you get bar back. Okay, so hash code table semantics look at equals and hash code. If the hash code's the same and it goes and first checks with the hash code, it first goes in hashes, then it goes to the buckets, and in the buckets it does equals. Okay, so the hash codes of these two guys, proxy and counter, would they be the same, or should they be the same, and would they be the same? They should be, but they're not, because I did export object. There's another way to do things, which will be more reliable. Okay, and if I print line proxy, what should I get? Will the toString of proxy be the same as the toString of counter?
But I guess it could also get in the way to show that it's a proxy.
So is the toString called locally on the proxy, or is it the toString forwarded to the?
It should be the server doing the toString.
Okay. As it turns out, the design decisions we've made prevent toString from being called in the server.
Wow. What's bad about that?
If I call toString in the server and there's an exception, how do I get to know there's an exception? Remember, it's a checked exception. The header of toString, does it have remote exception in it? The header of toString does not have a remote.
You could override toString with that exception, and then it would happen.
No, it won't happen, because anybody can call toString. toString is defined in class object.
But I'm saying if you override it in your class and then throw.
But no, because if you declare no exception in the interface, you can only override it with exception. Because everybody has that interface will suppose that this type of thing won't throw any exception.
So here's the deal: when you override things, you can't add restrictions.
Yeah.
If I had a public method in a superclass, I can't make it protected, because wherever I'm used, I can be used wherever my superclass is needed. So I can't provide. I can relax things, but I can't add restrictions. Okay. So the answer here is true, true, false, and you get some proxy toString. It's just called locally. That is again something I change in Gypsy. I call toString remotely because I don't have this checked exception thing. Okay. It's my client. I look up counter one. I look up counter one a second time. Okay. So from the same counter, I look up twice. This is the kind of question you were asking. So there's counter 1-1, there's counter 1-2. And I do then look up counter 2. Okay. So is counter 1-2 equal to counter 1-1?
No.
Why not?
Just have two different pointers.
But they're pointing to the same object. Couldn't the system be smart enough and say, I've already got a proxy to counter 1, let me just give you back the same object. You're doing 2 lookups, I won't even go the second time.
Maybe the client can modify the first one.
If the client modifies the first one, what does the client do? Modified what? Change the variable or change the proxy? Change the object. If they change the object, the underneath object is counter 1 in the server. The underlying object is the same. I've got 2 different names to the same object. My server could be smart enough, my client, my RMI system could be smart enough and say, I'm not even going to do a second lookup. I know I've done a lookup before with this name. I'll just give you back the same proxy.
So you would say?
But it treats it just as another client, so it's getting a new proxy, right?
Well, the client is saying, but yeah, it'll give you a new proxy, it'll give you a new copy. It'll go to the server, and each time it goes to the server, it just says, whatever object is registered there, I'll give you a copy of it. If it's a serialized object, I'll give you a serialized copy of the serialized object. If it's a proxy, I'll give you a serialized copy of this proxy. But the lookup always does a serialized copy of whatever is in the server. Okay? So counter 1, 2 equals counter 1, 1 is false. Counter 1, 2 equals counter 1, 1. Why? What value are they saying? Is the same? So is the equals method called locally or remotely? ToString method was called locally or remotely? Because?
Because there's exception.
For same reason. Equals is called locally or remotely?
Local.
Should they return true or false?
Why can equals not throw an exception?
Because equals has been declared an object to not throw an exception.
Well, it's not.
Then how do we do it
Yeah.
last time? Because we were on the server, like, how do-
In the server, we were the same server, you know. At that time, the equals was being called on counter. It was not being called on proxy.
but then internally, when you go to the equals method, it then calls equals on the proxy.
No, it goes and does get value on, sorry.
Oh, because you have value, okay. Okay.
So see, this is not so easy. If you look at the subtleties here, and again, because I implemented an RMI system, I sort of, understood the subtleties myself. So counter 1, 2 equals counter 1, 1, true or false?
It's called locally, I think
It's called locally. Why false? They're both copies of the same proxy stored in the server. Name server. Counter 1, 1. What is counter 1, 1? What does it have locally? Locally, it has the name of the server, and it has the port number of the server, and it has the object name. So it has some way to get to the server.
So it's,
I mean, if the proxy overwrote equals, then
That's the question. Even if it overwrote proxy is given to us. We never got a handle. We never got a reference to the proxy class. That's the proxy class is something we never touched. Proxy class was generated for us from the base class. Yes, the base class could override equals, which is what we did. But it can't go and say throws remote exception.
sure.
I just wonder if the hash code will be copied.
Okay, so let's go and figure out first counter 1, 2 equals counter 1, 1. True or false?
I don't know.
Two proxies to the same object. Both proxies were copied from the name server to the local computer. So they're serialized, they're copies of the same. The proxies themselves, whatever they have state they have locally is the same.
Okay.
Because they have to reach the same
I
object.
just still don't know what equals method is being called right now.
It's the proxy equals method, which we don't know.
Okay.
It's the proxy equals method, but the proxy equals method just goes and says, am I pointing to the same object?
Okay, so if proxy thinks that they are equals, they are equal. Okay.
And the proxy does know which object it's pointing to. And it goes and says, when I'm calling equals, when I do the equals, I'll go and see whether the other object is pointing to the same object I'm pointing to.
Okay.
And how does it know? How is the remote object identified? With a name, and a port number, and a host. So it just goes and says all three things are equal, I'll return. Okay? Counter 1 hash code equals counter 1 2 hash code. Who knows what's happening with the hash codes? Right? Maybe true, maybe false. Counter 1 equals counter 2.
Yeah. No, because they're different properties.
They're different proxy. Yes. Even though underneath the object, is the same, the names of these objects are separate. So that will be false. Who knows what's going to happen with hash codes? So let's go and see. Okay, false, true. Indeed, these two guys have the same hash code. Okay. And false, and you get proxy. Okay.
Which makes sense on the hash, because the hash code is just some representation of the internal, and that's intended to be used, to feed into, a hash map or something.
Yeah, but the intention is that if two objects are equal, the hash code should be equal.
Right.
That's the sort of thing. And so somehow the fact that these guys ultimately point to the same object was lost. Okay? And that has to be somehow taken care of.
Well, it's kept in the first one.
Yes, because yes. So this is what Java's doing. Ideally,
They do point to different objects, because they're going to counter 1.
yeah.
The second,
But because counter 1 2 equals counter 1 2 equals counter 1 1, the hash codes are same too.
right.
The equal and hash code are implemented together. So that is done. Because these two guys are not equal, the hash codes are not equal.
Right.
Yeah, I understand the hash code is based on the content of the
Yes.
object.
Yes.
But I thought it was like a pointer. So once you copy remotely, I just wonder if the hash code will be.
No, it's not a pointer. It's a value that's computed.
Okay, yeah.
If it's a string, the hash code will change each time. But if strings don't change, they don't mutate.
Yeah.
That's part of the reason why strings don't mutate, because you don't have to worry about computing the hash code each time. But I have done this often. I've used an object as a key. And then I've changed the object, and I can't get back the value when I use the object again as a key.
Yeah.
Okay?
But you can overwrite the.
Hash code, yeah. So, could you go and add equals in the remote interface? And then you would have, so could we do that, by the way?
No.
Why not? Because we discussed. Sorry? It's restriction. And here's the sort of funny thing. This is an interface, right?
Uh-huh.
Is interface a subtype of a class ever? No, right? But equals is defined in class object. So is distributed RMI counter a subtype of class object? But it is.
Everything is a subclass of the object.
Yes, well, but interfaces.
Interfaces don't do
Every object. So,
Yeah, so it's just again just a design identity. I wish object had an interface, but anyway. So you can't do this.
I would think that you could do that, but you couldn't actually declare any class to implement that interface, because then there would be a name conflict. That would be my idea of how things would work.
Yeah, but I think you want to give the error as quickly as possible. But you want to be lazy, all of these. So the problem is that when somebody does counter 1 equals counter 2, the exception is not caught, so we looked into this. Okay, problem with the remote exception being checked and a proxy being an object. So, proxy has to have the same method. Proxy has to follow the equals signature that's inherited from object. So cannot call object methods remotely. That's a limitation. Okay. And I have object editor, and my object editor uses toString all the time, and my goal was that object editor will run on one computer, and the object that is displaying will run on another computer. So when I do that, and if I use RMI semantics, I really can't make object editor work. So that's another reason why I had my own, my own. We're running out of time. Let's just take 2 more minutes. To understand this, so let's say I have a repository with an array list of objects, right? So this is my repository, and I go and register that with some. Okay, so I went and registered that with the server. Okay, so I put that repository there. Now here's my client. This is the first client that's going to access the repository. So the whole idea is that this is a repository. Different clients can go and deposit objects with that repository and get back the objects that other clients are depositing. That's the basic idea. So what does it do? It gets the registry, it finds the repository, it creates a counter, it deposits the counter, it increments 1, and it goes and gets back the objects, gets all the objects in the repository. And the first client will just get its object back. Right? Now, I'm going to get back my object. Should the object I get back be the same as the object I got? Should the object I registered locally be the same as the object I got back from the repository? In other words, when I go and say look up, so when I just get the object from the other end, should I just get back the object I registered, or should I get a proxy to that object?
Deposit a proxy, right?
I deposited a repository, yeah, a proxy. So I should get back a proxy. So the equals to return false. So I took an object, exported it, I deposited it, got back another object. That's now a proxy. So, right? In Gypsy, it'll return true. In Gypsy, it'll say, you just given me, I just got back a proxy to a local object. I'll just go and return to the guy the original report object, local object. So it'll be false. If I run it a second time, another guy, it'll be again false. So no matter how many times if it's another client also, it'll be returning false. So not only are 2 proxies to the same object not equals, but a proxy I get back to an object I registered is not equal. It's a proxy. It is not the same object. Okay. And again, in my system, I just said, hey, why go through indirection? I have the original object here. I know that. So I'll just return back that object. Okay. We were looking at a situation where multiple clients are sharing objects with each other. So it's not as if there's only one client and one server. And what happened here was that some server, some well-known computer, went and exported a repository with the name server. And so it basically is trying to act itself like a name server to some degree. Okay, but it's maybe defining some narrower scope. And it went and gave it a name to the repository. And now these clients are all equal. So a client goes and creates a counter, deposits it, increments it, and then goes and gets all the objects in the repository, and goes and says, prints out their value, and sees whether any one of these objects is its object. Okay, and when
the value or the object ID?
So it's going and checking the object. So it's trying to use equals. If it did get value, that would work for sure. But then we don't know whether it was its object or somebody else's object. So it's trying to figure out whether it was its object. Okay? And when you print the value, you do get object with the value that you sent. But RMI will not tell you whether the object you got back was your object or just a proxy. It just says whatever object there was, I'll send you back a serialized copy. So if it was a proxy, I'll send you a serialized. So what you did when you actually did the deposit is not go and copy or exported counter, but you actually copied the proxy. Okay, and you get back a proxy. Okay. So if somebody else now goes in, if you run another client, it'll go and see the object distributed, stored by this client, and also it'll see its own objects, right? If you run this program a second time, it's a different client now. So you will get back one false again. Okay. So again, it's just the argument is just an extension of what we gave before. Okay. These RMI objects is different from what you would see in any tutorial. Okay. You never see the export object explicitly done. And what I did was I created a distributed version that inherited from a non-distributed version. Okay, I'm assuming there's a non-distributed version. I want to reuse its code. I have to go and override equals, but other than that, I can just use it. Okay. So have any of you used RMI from a tutorial or used RMI before? No. So the way every book and every tutorial will tell you how to do this. Okay, so there's always two ways to share code, right? You can always inherit, or you can do what? Software engineering concept?
Composition.
Composition, or what's another term for it? Start with a D? Delegation.
Delegation.
Okay, so basically it's the same idea, right? I can inherit from my parent great functionality, or I can delegate to my student or my assistant the functionality. I can delegate to multiple, any number of students as I want to. I can inherit only from so many people. Okay, and that's kind of innate to me. Whereas what I delegate, I don't have to be, I am not a assistant, I'm not a student, but I've delegated to a student. Whereas what I inherit, I better be a of, from a pure point of view. Okay, so rather than go and inherit from a counter, it can delegate to counter through composition, as you mentioned. And if I go and do that, I can go and inherit from unicast remote object. Okay? And basically, I don't have to put the super, I just put the super in, I guess, supposed to make a point that the super is being called. And when this happens, what could that thing do for me? What could my superclass do for me? It could export, just as Plus, it could make sure that the hash codes, my hash code, the hash code of my proxy, or my hash code is the same as the hash code of my proxies. Okay? So, when you export, it goes and sets the hash code somewhere. And I don't know what happens when the object changes, how you keep the proxies hash codes consistent. But there is a distributed garbage collection mechanism in RMI, either part of RMI or somebody proposed it, where you keep reference counts and you go and figure out how many clients have access to it, an object, and you prevent an object in a server from being garbage collected if the clients reference it. I'm not quite sure how it works, because after all, no client may reference it, and yet you might want to keep the object around because some other client in the future may reference it. But there is some way to get to be able to contact all the clients.
I think, but in that way, you should be you should explicitly cache it, but not like let it stay around, right? The object without any client reference.
No, but when the server first comes up, there's no client, right?
Yeah.
So it sends it to the name server.
Yeah.
For a moment, there is no client.
Yeah.
So I destroy it immediately. So, but there is a distributed garbage collection mechanism I've read about or seen, maybe in the context of RMI or maybe
So
not.
you are talking about the proxy, or
Yes, I'm talking about the objects in the server.
Okay.
As long as a proxy points to an object in the server object better not be garbage collected.
Okay. Yeah.
Right?
Got it.
So, I should go and turn this off. Okay, hopefully it'll. Okay. So that's what happens. So we extend unicast remote object, and like I said, if that's a proper way of doing it, because your hash codes are the same. Oh, yeah. So your super better throw remote exception. Your constructor better throw remote exception. Okay. So superconstructor automatically exports object, correct semantics of hash code, and has a link, requires more work, but it's more flexible. In fact, the history of object-oriented programming languages is that people use inheritance everywhere, even when they shouldn't be using. Then Java 1.1 came around, and many things that were done inherited became delegated, and now inheritance by default shouldn't be done unless you really, really think it's the right thing to do. Okay, so delegation. The same example we did earlier, where the hash codes returned false for the counter and the proxy that you get back from the counter. Okay, but now my hash code, so the equals counter and equals proxy one will return true. Okay, because we did the equals correctly there, and now all three things return true. Okay. So let's now start summarizing. Okay, this will be good for the quiz. So we have some remote object in some server, and we have some caller that wants to access it. What do? We create first a proxy through export, directly or indirectly, implicitly or not implicitly, and then we send the proxy to the RMI registry. Right? And that is then looked up by the caller. Okay? And now we've got a path that is directly to the object. We don't have to go to the server for our communication. That means in the server, some host and port number got allocated, and we can specify while doing the export what the port number should be, or we can pick the default number. Okay, so underneath there's not NIO as sockets, but you can assume that there might be NIO too. In fact, the system I created is flexible, that the lower layer can be changed, and you can either have NIO or sockets underneath the remote method invocation layer. Okay. So in fact, one of the assignments I gave 4 years ago was that they replaced the NIO layer, which is the default layer. The students changed it to socket layer using the same RMI language. Okay. So the RMI registry can be run as part of Collie, and if the caller is a well-known computer, maybe even the caller, but I would just regard this. That doesn't make sense at all. Okay, because that means that the server knows then the question, which is the server, which is the client. So we'll just assume, and for the quiz assume that too, that the caller doesn't know about the Collie statically at least. So the Collie doesn't know about the caller statically. The Collie may discover the caller dynamically. Okay. So then that's the distributed architecture. Here are some libraries that you can use. So registry, which allows you to rebind, which is basically register and look up. Okay, and these things take. I don't think this has to be remote. We saw that we can send a serialized object also. So this is. I don't think these things have to be remote. They are remote when we are doing RMI. But if you're not doing RMI, registry will take serializable objects also. Okay.
Does the name have to be unique?
Yes. That's what it's called rebind. So if you give it the same name again, you're binding the name to another object.
Oh, okay, so it'll just dump them.
So it'll never give you an error.
So so your clients have to coordinate
the client and server. The client and server have to coordinate.
But if you have multiple clients, does that become a mess?
No, the rebind is done by the server, right?
Mm-hmm.
The server can first bind it, register it with one name, register one object with a name, then it can register another object with the same name. That's why it's rebind. And the clients, the clients who looked up the object earlier looked up the name earlier will get the original object. The ones who looked it up later will get the later object.
So it tracks it with clients too. So it knows, because the clients don't have to coordinate. If one client registers counter, and the other
No. Clients don't register. The server registers.
The server registers.
That's how we'll define. Yeah.
So you can define your own a sequence logic in the server side, right?
Okay, yeah, all right, that, yeah.
Yeah,
you can
find out if
The remote methods all live on the server.
yeah.
They're called, they're not yet sent up.
Yeah.
Okay.
Yeah, okay.
Sorry.
Okay, so the caller goes and calls the lookup, and the callee does the rebind, right? And then there is a locate registry. Okay, that actually creates the registry. So you can create the registry on any computer, and then you can find, once it's been created, somebody can look it up. And that's done in an underneath, that's done with host and port numbers.
So you can create a standalone locate registry.
You can create as many registries as you want to in any process.
So it's quite like the DNS server. Okay.
Exactly. It's a name server. There's no hierarchical thing built in,
Okay.
but that's exactly what it's at a higher level
Mhm.
because you're getting about object references, okay, not IP addresses.
Right.
Okay. So RMI registry, the process will do and create itself, and then somebody can locate it. Okay. So the caller and callee will go and get the registry, okay, and they need to get the registry to be able to look up and rebind. Okay, you're always the one at a disadvantage. Okay. And then there's this unicast remote object that you can subclass. Okay, it has a static method that you can call if you don't want a subclass of it, or if you just subclass of it, the static export object is automatically called. Okay, and there is export object with the port, and there's another export object. Oh yeah, there's only one export object, and you can give the port number to be 0 or not.
So when you extend it or implement or inherit, then it just will automatically call export in the constructor with the default port and this as the
Yes,
object?
yes, exactly. I assume that's what it does, and it does some magic with hash codes. And I don't know what exactly that magic is, because if hash codes depend on the content of the object,
Yeah.
how does it make sure that the hash codes are kept consistent unless the hash code call is somehow forwarded?
Yeah.
Okay.
You can select a field from the object to generate the hash code, right?
You can do what?
Select certain fields like
Fields
certain properties of the object
to be.
create a hash code so that you can.
Oh, so what you're saying is, I like that.
Yeah.
So the proxy somehow has the same code.
But you want
I did it
specific
for
to-
something.
You want it specific to the proxy and the object, because if two counters have the same value,
Yeah,
it
yeah.
doesn't mean that they're the same object.
Right. So what you're saying is that whatever code there is to update the hash code is executed at both ends. But that code isn't class object anyway, right? I mean, hash code is inherited from object.
But you can override the hash code like I did it for one of my projects. Like I have an ID for each object, and I just use the ID. I just hash the ID of the object so that every object with the same ID will be same. Will be.
So this is very interesting now.
Actually, the Apache Commons has a library for generating the hash code with a certain.
No, but what if my the hash code can be overridden, right, by my distributed counter?
Yeah.
So how does the proxy how is it that the proxy will have the same hash code? Unless it has that overridden method somehow. So maybe what this will do is, what will it do? It can go and do reflection on the object and say, do you have a hash code method?
Yeah.
Okay, but how does it make sure that hash code method is executed in the proxy?
It could also hash the delegated out thing and hash itself and then add the two.
No, but what I mean is that what if my distributed object always returns 0 as the hash code? Just overrides and does some nonsense. How do we make sure that the proxy also returns 0? Unless we forward the call somehow. Underneath we do some magic there. We forward the call. If the forward call has an exception, I got to look into more whatever I've seen on the web just says it correctly does hash code, whatever that means. I think there are some constraints that you must follow when you override hash code. So you can't just go and return 0 each time.
Actually, if you override it wrong, it won't be called. I tried it before, but I'm not sure what happened when I tried to initially I override my hash code with like it give an integer or just a string, and then I tried to determine an object is contained in one set. But it turns out I put it inside the set, but it tell me it doesn't exist in the set. So that hash code actually not being called. If you
it'll be called. It'll just be called wrongly, right? What does the hash map do? It goes and first checks if your hash code. It finds your hash code, tries to find a bucket chain with that hash code, right?
Yeah.
If you went and then it goes in the bucket chain and tries to do an equals.
But I put a static value there, so it should be some value. It should be a static value.
It's a static value. So basically, you're saying that. So I think it'll also go and it checks, makes some check that if two objects are equal, they better have the same hash code. Yes, that is the constraint that it puts. Two objects that are equal better have the same hash code. If an object have the same hash code. Two unequal objects can also have the same hash code. That's hashing, right?
Yeah.
But two equal objects better have the same hash code. So they go to the same bucket chain.
Yeah.
So.
Oh yeah. Oh, I got it.
Okay.
Yeah.
That's what you remember how hash tables work.
Right.
You go in first, hash the object, then you go to the table, figure out what buckets are linked from that thing, and then do an equals on.
So you mean first thing you find out these two objects, and then you look into more
depth.
detail to tell if they are different. Or
Yeah,
not.
because the hash table has
Okay.
hash code is not the same as ID.
That might be okay.
So that's what happens. Okay. Is built on some sort of data communication layer, which is actually very nice. It's not built. It's built on a data communication layer, and not only data communication. It's not built on a byte communication layer directly, but an object communication layer, which is very nice. I mean, I've seen earlier systems where they did remote method invocation, but you never got the notion of serialized objects, though objects have to be serialized by RMI, right? So you must generate a proxy for it and register the proxy in an RMI registry, and the process must go into a lookup. The lookup must be done after the register. The server could look up the client too, but then that's kind of a funny thing. The server knows about the client. So normally what will happen is that the client just sends a reference to itself, okay, as a parameter. If you just send this as a parameter to some remote method of the server, that this gets automatically converted into a proxy, and the proxy is sent to them. Okay.
Wait, say that again.
So supposing I've got I'm an object on a client, object A, and you are object B on the server. To get a reference to object B, I must do a lookup, right? Let's say the lookup is a method, and the looked up object has a method called register client. So I call register client on B now, sending myself. I just do this.
Yeah.
This is automatically exported now.
Okay.
It's not really exported. You don't really have to, it doesn't get sent to the name server, but a proxy for it is sent to you.
Okay.
It's not sent to the name server, but a proxy for this it is sent to you, and you can now invoke methods on me. But other clients can't. Other clients don't have a way of getting me because I don't have a name.
So it's not serialized sent to me, and then the proxy's made. The proxy's made before.
So yes. So what happens is the export object creates a proxy, right? If you think of export, so an object is exported. It's just not rebound. So the object is exported automatically,
Okay.
and then a copy of that proxy is sent to you. And in one of those slides, I mentioned how serialization does the same thing too. I mean, this is part of serialization, that there's a method that it calls, and it goes in the object output stream calls a method in some registered object to see what it should do. And the RMI system goes and says, hey, if it's an RMI remote method, I'll send a proxy, I'll give a proxy to you. Otherwise, I'll give you the original object. And then the serializer goes and serializes that object. Okay, in one of those slide decks, I mentioned that sometime. Okay. This is a term I also talk about, marshalling and unmarshalling. So when you make a local call, there's a notion of an activation record, right? So when I make a local call, there's an activation record that gets put on the stack. Stack grows. The same thing that was going to be put on the stack now gets sent as a message. And all the parameters that were going to be in the stack get marshaled and sent to the other end, and that record gets unmarshaled and results in a stack being increased at the other end. The stack goes up here too because you make a proxy call. But that
Marshalling is just a smaller version of serializing.
there's a larger version of serialization.
A larger version.
Because serialization just takes one object. Marshalling takes a whole stack, activation record. And it has to find the remote method on remote, it has to also find the remote object on which to call the method. So calling that's what I'm saying. That RMI, what people used to do was take sockets and build a remote RPC on top of it. That's what I did when I built my C RMI a long time ago. These guys have done it more modularly. They say, let's go and first have the concept of sending an object across the network. Then we'll go and have the concept of sending parameters and invoking a method, which is nice. Now, I don't think they've done it in a very modular fashion that I can just change the serialization layer and put my own serialization layer, which is what I do in my system. That, I've got a remote scheme, you guys will go and change your serialization scheme underneath it, and it'll use your scheme now. And similarly, you can change your byte communications structure, and it'll use your structure. Okay, so that was quite a challenging task for me to do that. I spent a whole summer doing it, or maybe even more. So the errors that can occur when you send a message across are not under the control of the programmer, so that's why there is a checked exception. Okay. So this means, equals to string and hash code that don't acknowledge this exception, are not supposed to throw this exception, cannot be invoked remotely. Okay. And so, in our project, we have to create a model, and it's got a view and a controller, and we can't just take the model as such. You have to change the model. That's going to be a pain for you guys. You're going to have to change the model, make it RMI aware, and then be able to, no, sorry, I'll take that back. You don't have to worry about it because you just can do it with couplers. You're not keeping a central model. I've had projects in which we had a central model too. Okay? So you guys are just replicating the model, and you're fine. You just can go and have your couplers be distribution aware. Okay? So each remote object underneath is connected to some server communication channel. Okay, some channel is established. Okay, and I think because the export object can take a port number, arbitrary port number, different objects can be bound to different channels. So you don't have all the messages. Supposing you have a server with 10 objects, all the messages don't have to be funneled through one socket.
So one channel will occupy one port, right?
Yes.
Then you have a scalability problem.
So that's why they're saying that you can export object takes a port number. So I can have, if there are two objects that are heavily used, I can create two different sockets for them, or two different underneath channels, by having a different port number for each object.
Yeah.
You're saying that it'll be a bottleneck, right?
Yeah, it will be like it.
That's why if you do export objects, if you do export objects 0 each time, then it'll become a bottleneck. But if you say export object 1099 once and 2099 the second time for another object, then two different. They're all going through the same computer, so that's a bottleneck. But at least that channel is not. Now I don't know how many programs actually create multiple socket connections to a server.
I mean, you have like a limited number of ports on the computer.
Okay, so that's another big deal.
You don't multiplexing it in this case, right?
So here, when you do export object 0, you're multiplexing it, right? You're using the same one.
Okay. Yeah, I see.
You have a limited number of sockets. You have a limited number of ports.
Yeah,
The number of sockets is even more limited than ports. You can easily run out of sockets.
Yeah, right.
That happens to me all the time on my Windows machine. Okay. So in RMI, two proxies. In RMI, a parameter to a remote method is sent by reference as a proxy if it is of type remote, and by copy if it is serializable. Right. In RMI, two proxies to the same object are not equal to each other. And if an exported object is fetched, a proxy rather than the original object is returned, but the equals method is locally called correctly. Okay, so correctly meaning that it will just check if two proxies are the same. Okay, questions?
How would you get the remote object to this one sends a method, but then can you have it both ways where you have another proxy to the underlying object that called you, so that then you can
Yeah, exactly. That's how you will do your project. The client will go and register itself with the server, and it'll send a reference to itself. And on that reference, the object it will send back. And you can get into a deadlock situation, if there are synchronized methods there. What happens though is that there is, so there's a special thread created. When a method is invoked on a server, it's invoked in some thread. And now the question is, if I'm a server and there are 3 clients, do I have one thread for all 3 clients? Do I have one thread for each client? Or do I have one thread for each client call?
So is it decided by you or?
No, it's decided by RMI.
RMI, okay.
And I do know that it's not one thread for all 3 of you. Okay? Which is what I did in Gypsy. In Gypsy, to just create more, to have more control over the order in which things are done, I create one thread, and that thread can then go and fork off. You can imagine extending it to sort of fork it off to multiple other threads. Okay? And in RMI, I believe, from what we saw last time, the same thread is used for each client, I think. It doesn't create a thread for each call. Okay? But that's a decision in the implementation. So my caller can be in one thread, and I can call a method in the server. The server can call back a method which will be invoked in another thread. So we're fine. As long as this object and that object are not accessing some synchronized object, then we'll run into a deadlock situation. And if that method calls back, if a single thread is used for each client, then if that called method calls back the server, then we'll run into a deadlock situation too. Right? So, client calls server, server calls client calls server again. Right?
Before the server.
Yeah, it's all synchronous. So that guy's waiting for me, I'm calling him back, and he calls me back now, let's say. Now that call is being serviced for the same thread that is servicing the previous call. So we get into it. That thread is not available to go and read the message. Okay? So the more threads that are created, the less the chance there'll be a deadlock. The fewer threads that are created, the more chance there'll be a deadlock. If I create a single thread for all clients, I might run into other, somebody else can go and prevent me from executing, something.
I think that's the
Most dangerous.
I mean that's the way they do in the web servers, most Java web servers. They even create a thread for every
Call.
HTTP request.
Yeah.
Handling. So.
Yeah, but the consensus now is that you don't call remote methods synchronously. You call them asynchronously.
Yeah.
If you do that, which is what Gypsy is based on, my system, then single thread is okay because the server is just not going to, the client is not blocking for the server.
server's not blocking for the client, and you just do it all asynchronously. Unless you make a function call. Function calls block.